So it looks like you guys are all good here. What's n? It's my sample size. 5 adults are selected. That's my n. Oops, what did that do? So my n is 5. Good. What's my x?
3.
3. It's my, so how do you find it? You find the probability of. That's kind of the probability of part. So I think I might have misspoken and said something else, but probability of, that's your 3. That's your 3. That's your x. And then p, what's my p? Yeah, so p is, it's kind of the general probability, right? One of my students described it as kind of the probability of the world, like the whole population, right? If you take all of the, all the people in the world, what's the probability that any of them knows that you pick one and that one person out of everybody that knows Twitter? 85%. If you pick one, the probability that they know Twitter is 85%. So then your Q is going to be what? 0.15. So find those right away. And then you can plug that in. So it's going to be 5, choose 3, times 0.85 to the third, times 0.15 to the second. Great. And what'd you get? 138. Terrific. Good. 3 sig figs. That's perfect. All right. Quiz problem 3. We do not need to find the probabilities. Just figure out what can x be. Right? So more than 5. The easiest way to do this, well, okay, so I'm picking 6 people. What numbers would be, how many successes could I have if I pick 6 people? I could have any number up to 6, right? So what's more than 5? 6. Only 6 is more than 5. Okay, great. Now, so x has to be 6 here. Now here, at most 4. So pick something you think that would be at most. At most, you can have at most 4 absences in this class before I kick you out. Okay, at most 4. So pick a number, it toggles around 4. Pick a number bigger than 4. Is 10 at most 4? No. Okay, is 1 at most 4? No. Well, I mean, does 1 fall into the at most 4? Would you be okay if you had 1 and I said you can have at most 4?
Yes.
You'd be okay with that. Does that make sense? You're not in trouble. So that means that the lower part of 4 is okay. Now, how about 4 itself? If you have 4, are you all right with if I say at most 4?
Yes.
So includes 4. So it means 4 or less. So what would that? So that's kind of the easiest way to do it. Pick the number you toggle around, put it in terms of something you're familiar with, so that your brain isn't like trying. It can spend all its working energy, working memory on the novel stuff, and not like the, what do you mean about VCRs and students, right? Just pick something you're comfortable with, and then play that game, so you know whether it's greater than or less than, and then find the actual number and whether that fits as well. So at most 4 would be what then, guys? Take 5 seconds with your neighbors and find those numbers. X could be what? Fill it in. Write it down. Okay, what'd you guys get?
4.
4, great. What else? 3, what else? 2, what else? Is that it? No, 0, 0 to 0. You can always have, you guys listen up. You can always have 0 successes. Don't forget that. Right? If I pick 6 students, is there a possibility that none of them will own a VCR? Yes, you can always have 0. Don't forget that. In this binomial thing, 0 is always a possibility. You can't forget it. All right, so you guys do at least 4 and less than 3. Take a minute with your neighbors and find those 2. All right, so let's take a look at the first one. At least 4. What's something that you can think of that you can wrap your head around that's at least something? At least
4.
At least 4 whats? Chickens. Do you guys all have cookies? At least 4 cookies. All right, sure. All right, so then if I have 10 cookies, do I have at least 4 cookies?
Yeah.
If I have 1 cookie, do I have at least 4 cookies? No, so it must be the bigger half. If I have 4 cookies, do I have at least 4 cookies?
Yes.
Yes, so it's 4, includes 4 and goes up. So what numbers are those?
4, 5, and 6.
4, 5, and 6. Great. Why do we stop at 6?
Because that's
Because-
the most of all.
Yeah, because that's how many people we picked. We randomly picked 6 people. That's our n. All right, less than 3. What's something you're familiar with that's less than 3? No. But I mean, what can you wrap your head around?
0.
I have less than 3 whats? TVs. I have less than 3 TVs. So if I have less than 3 TVs, if I have 10 TVs, do I have less than 3? If I have 1 TV, do I have less than 3? If I have 3 TVs, do I have less than 3? No, so it doesn't include 3. So it's a smaller side, not including 3, so that would be what? 2, 1, and don't forget 0. Good? Okay. Give you guys 15 seconds. Confer. Okay, now you guys need to go to your chapter 5 notes. And it is not the last page, it's the second to last page at the top. So bust out your chapter 5 notes. Not the last page, the second to last page at the very, very top. Everybody has their chapter 5 notes? Chapter 5 notes, you can do those later. Chapter 5 notes. Second to last page. Second to last page. The very top. That's not the second to last page. Everybody, is everybody here? Yes? Good. Everybody out? Everybody there? You good? All right. Jacqueline, go ahead and read.
A survey from Teenage Research Unlimited found that 30% of teenagers have a part-time job. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs.
Great. So, first we define my random variable. The thing that varies. X is the number of teenagers from a sample of 5 that have part-time jobs. What's N and P? Those things are fixed. The number of teenagers I'm picking, right, the number of times I'm doing this is fixed. The probability of them are fixed. The thing that varies is how many successes I have. So everybody, for a second, take 15 seconds with neighbors and find my N and my P. Go ahead. Find N and P. All right, what's my N? 5. It's my sample size. I'm selecting 5 teenagers. That's my N, my sample size. What's my P? Little p, first of all, little p has nothing to do with X and N. Remember that? Nothing to do with it. The second thing is, little p is not, it's the small probability. It's the probability of just one teenager. What's the probability I pick a teenager and they work? Has nothing to do with X and N. Nothing to do with X and N. Does my coin flip? So some might say 3 out of 5. So let me ask you this. What's the probability that I have a coin and I flip heads? What's the probability it's heads? 50%. Right? Yes? Now, if I flip it 5 times and I want to find the probability that I have three heads, what's the probability that I flip 1 coin and I get heads? Just 1 coin. Still 50-50. That 1 coin flip is still 50-50 no matter what. Does everyone understand that? That's little p. Just that 1 coin flip. So you have trouble remembering that. Remember, the little p is just the 1 coin flip. It's not affected by n or p. It's its own thing. Everybody okay with that part? So the little p is what? It's for the whole population. So it kind of, if you think about it, like it's like it doesn't have anything to do with your n and your p. It's about everybody. Out of everybody, what probability? What's the probability that they have a part-time job? 30%. Good. So I think that's kind of the better way of thinking about maybe little p. So little p is 0.30, which means that little q is what? 0.70. Great. Now, x is my random variable. That means it varies. It's going to be random. It's going to vary. It's going to vary. N and p are fixed. So let's take a look at that for a second. Everyone's my own problems. The n and p are fixed. They do not change at all, ever. X is the thing that changes. So x can be anything from what to what? 0 to 5. My x will vary from 0 to 5. Depending on that, this big P, the probability will change. Little p is not probability. We call it little p. This is what we call probability of. That's the thing that depends upon x. Is everybody clear with that part? The little p, that's a fixed number. This is a fixed number. These are just part of the problem. So my x varies. In this case, I want x to be what? At least 3. That means how many? What's at least 3? 3, 4, or 5. Good. So this means 3, 4, or 5, which means that if I find the probability of it, it's going to be probability of at least 3. So this is your, you guys are writing this stuff down in your notes, right? Is equal to the probability x is 1, or the probability x is 2. Sorry, are those right? No. Help me out. X is 3, or the probability x is 4, or the probability x is what? 5. Everybody on board with that one? How can it be at least 3? It could be 3 or 4 or 5. Ors we add, so we're going to add these. I'm sorry, what was that? What? Oh, so you have to find this one, find that one, and add them up. Yeah. All right, so let's find the first one. Probability x is 3. That is, and choose x, 5, choose 3, times little p to the x, so 0.3 to the third, times little q to the n minus x, so it's 0.7 to the, if I have 3 successes, I must have 2 failures, because these 2 numbers have to add up to 5, my total. Please also notice that, again, you guys look up, my n and my little p and little q, those are fixed. The only thing that varies is my x. So these things, these are my x's, they vary. And then what's left also varies, right? Because these two, if I have more successes, I'm going to have fewer failures, right? These two successes and failures have to add up to my total. So the more successes, the less failures. The fewer successes, the more failures, right? My successes and failures, if I have 3 successes, I have to have 2 failures. So, are you understand what I'm saying? I'm picking 5 people. So some of them will be successes, the rest will be failures out of those 5. So these 2 numbers have to add up to my 5 people. 3 of them were successes, so 2 of them were failures. All right. You guys find this number and then also find this one. Find this probability. Probability x is 4. And find the probability that x is 5. And then add them all up. So take a couple minutes and do that.